Sup, dude skis. So I was watching this channel. Pardon me, I know you guys are gonna have to just accept me as I am. Okay, so with that said, I was watching. Let's see. Basically, been trying to look into Australia, just kind of watching some YouTube videos. Came across this channel, which had orogenic gold deposits. So, let's see. Let's go through my notes first. Did I say this yet? No, I don't think so. Okay. Let me find where I last left off. Okay. Probably here. Okay. So I just wrote down this thought. With all the accretions, I know, like, what a great way to start with some ridiculous thought that no one's gonna be willing to listen to further. Okay. But with all the accretions going on in Alaska and British Columbia, it just made me think of the potential for there being, like, equivalents of protons and neutrons and electrons in the region where, like, batholiths are one thing, monoliths maybe. Let's see what the difference of a monolith and a batholith is. What is a monolith? Oh, why did some? I feel like someone used the word geologically. I see. I see. It's like what? How does this differ from a batholith? Mono gives me the impression that it's truly singular in some type of geological nature. Large, well, no. Difference between monolith. A regular mass of intrusive rock that has melted or forced itself. And while monolith is a single block of stone. Okay, this again references, it doesn't in any way even acknowledge the geological term. That does seem to be a term. Okay, anyway, let's move on. I was just thinking that. I thought I'd throw it in there. Proton, a sphere with an inlet outlet. Neutron, a sphere with a sealed inlet outlet. Tau key, and then an electron would be probably like a metamorphic rock. Probably would be more like an electron cloud. Maybe is my thoughts. Just an initial thought. If there were to be some kind of parallel across them on a plane of existence that we could put in a large scale like that, then that would probably be like the electron equivalent. Is something that's more like heat, some heat current flowed through it, sort of like a disk of a galaxy, rather than being like a central nucleus object, some massive thing that like takes up space and makes like holds the space of the system pretty much, and can be either with currents or like without currents in some way. That's like it currents can't easily get in, so it's more of like a neutron, where like the difference between a neutron and a proton in terms of their mass is very small, and it's probably like literally like the inlet is sealed in the case of a neutron because the current has like solidified and blocked the seal and like created that seal's additional mass to the system itself. Okay. So, Talkeetna Mountain Batholith, which is in Alaska. These are just my notes. Let's see. Bring this over, I guess. I was watching some atom related stuff, but okay. Over here too. Over here, I believe it's around here. There it is, Talkeetna. So like it's generally this region. Pretty close to Denali, I guess. There's mountain must be somewhere around here. I don't know. But this place is a batholith of 74 to 67 million age or of emplacement when it was put there. It wasn't formed there, it was put there 74 to 67 million years ago. And then I wrote residual topography. In part, it is a residual topography. It's not like a complete topography. It's a residual that formed in response to a Paleocene-Eocene thermal event. Paleocene is in this time frame, and then Eocene is period after, from 55 to like 20 something, I think, 34. Love it. Okay, so that made me think of like the heat of the supernova. So what I'm consistently going to be referring to, if you don't know what I'm talking about, you gotta watch my previous videos pretty much, is that there was a supernova, if you will, equivalent of a small particle, relatively speaking. So it wasn't like a star, but it was a system that was forming in this region that novaed and had effects throughout the region that are, as we're going to be talking about, are kind of supernova-like, honestly. Like, so like that right there. The in part residual topography that is formed in response to a Paleocene-Eocene thermal event. Like, what's a supernova do except for like take the thing that's together and just like disperse it in a thermal event? So if there's some like distribution of thermal energy in the process that maybe isn't like completely uniformly distributed, but instead is more focused beam-like into that region, like from here, the radiation of the energy propagating like a jet this way, which was over here, propagating up this way, and pretty much just right to that region. So maybe not only there, but I'm sure. So I was thinking like maybe these are like different decay sequence alpha particles being released that are then being embedded over here for some kind of exchange across the systems of everything going on to bring balance, to allow for equilibrium to emerge. Alice Springs origin. This one's real interesting. This one. There it is. Where is it? Right there. At like the eye at the center of Australia. Let's see, what can we... I want to look at gravity anomaly. I don't even think that's the one that I was looking at. That one's pretty good. It's probably this one. So let's see, when did this even happen? I don't know when this formed. Ew. It's like it decayed until 300 million, and then it no longer could decay, so instead it started to decay in like subtler ways, because essentially Australia, there's basically all these currents that were focusing here in this location that had a outer ring that took shape, that got carved apart, but still has like the outer ring remnants, and then a nucleus that also got carved apart that formed an ammonite shape here. But initially formed just from compaction from the currents, creating like a large region that then had its nucleus invaded by this side current that managed to break through the boundary and get into the internal region and just swirl energy through until the system decayed to a new stable nucleus that's actually more centered on Australia, where that was up here. So like that supported not just Australia but this region, and this here was down here. Philippines were down here, so they were kind of involved. It actually even went over into this region. Over like just past this was California. I was about to say Philadelphia. Past the Philippines was British Columbia. And then Borneo was down past the Philippines. And exactly what was going on, I'm not sure. I was hearing something about Alaska forming in the last like certain amount of time. That's more recent, almost like only a part of it existed. Like maybe maybe it was more up this way than I realized, because I put it this way. But maybe like this segment is like, I almost want to say like a huge pillow lava. Like something that came out and just created an underlayer to support the general region where the lava itself had a boundary, but then it just like came out the side and created a lobe there. Something like that. That lava does do, but I'm not sure if that's what happened here. It's just like I just don't know, because there's so much like explosiveness in the region that it's hard to piece it back together. Okay. Woodruff thrust barely visible at ground level in that region. I just wrote that. Okay. Here, the gravity anomalies in this region. The gravity anomalies are in regions with faults filled with mantle. So these faults where the gravity anomalies are, which have like high gravity, so there's a lot of mass there. These regions are filled with mantle, much denser rock. So I've been saying that the mantle was flowing, and this is like the mantle was flowing, and it's almost like initially it flowed pretty chill everywhere until it started to like build here, and then the mantle like outwelled here, and then it started to open up and cause just differentiation. I don't know, which was around when the Siberian traps and the supervolcanoes here were going off around 250 million years. Something. Yeah. Yeah, that's true. Okay. I was like, what is that? Red banked shear zone, greater of two anomalies along the Arunta region. I just wrote that down. I just wrote down some information. Ormiston Gorge, heart of gravity anomaly. This was a YouTube video that was like maybe something about gravity anomalies in Australia, Alice Springs. Something that also, things about Australian geology that you don't know or didn't know or hadn't heard or something along those lines was in the title specifically. Okay. Ackerman, because I don't have these videos open, I was just kind of taking notes. Ackerman impact with eject classed ring. So this one I found interesting. Maybe I can just find it. YouTube, actually, they're right there. It was this one. This one, okay. So that's the one I'm referencing information from. Ackerman impact. Let's just Google it though. Ackerman impact. Apparently, I even was curious enough to search it then. Oh yeah, that's this one, which is actually really interesting. This one's real interesting because it's right here, looking kind of hexagonal and almost double hexagonal, oddly. Like two overlapping. It's not even. Like, how is that considered an impact if it has like a double aspect to whatever just happened there? Really interesting. And then it has a larger structure around it. But then it has, at least in my eyes, I don't know if it's actually considered to be a ring around it, but it certainly has one. Like through here, across here, and then down this river here, up this way. Even a smaller hexagon here. Whoa. Like, if that's an impact, then what's that? This is 580 million years, so this is like the first. So it must have been that the vortex weapon was used around 600 something million years, and then the first subtle detections of it was things like this, all like around the globe where the pressure started to converge, but then it started to build pressure everywhere because it was just flowing current everywhere, although it was focusing over here more so in a way where it started to like. And here, from what I'm understanding, it was in an ocean, so there's also water here, just like in North America, there's water involved. So, like, this isn't just doing it into pre-existing continental crust like here, it's doing it into maybe more like this. Something with water involved. Or even like up here, like this region where the pole structure is in this. Okay, let's move on. But so, ejecta ring. I found the ejecta ring interesting. Ejecta. I think one of those actually showed it. Here it is. Okay, here's the impact we were just looking at, and then here is its ejecta. So if we go back, it's kind of here past this structure, so it's kind of over here and then up here, so it's nothing that's like immediately visible in the satellite imagery. It's not like it's. I was thinking maybe it was like places like this had it. Then I'd be like, what are we doing? But it's not, so it's just there. But the thought that I had was it's reminiscent of like Mount Girnar, um, Grano Fire image. Whoa, let's check this out real quick. Oh my god, they even have Datatrea Peak in this paper. Wait, is this this is the paper? Is this seriously the actual paper? Oh my god, it is. I never noticed. Oh, I did notice. It's just not central. I was thinking it might be actually more central. Like, like I don't think they do more than just to like reference. Anyway, pardon me. This here though is Grano Fire, and then a dike or sill, I think dike, ring dikes of Grano Fire here and basalt here. Basalt is within a hexagon of olivine gabbro, and then the Grano Fire is within a hexagon of basalt within just the overall Deccan Traps basalt, but a hexagon of basalt within that. Within this hexagon is the ring of Grano Fire, and then within this hexagon is the ring of basalt. So like that happens in places where there's currents swelling. Like here there's currents involved that are ultimately swirling in on and then causing differentiation and just like a peak to emerge out of the location. See my Mount Girnar videos playlist. Okay. But I just thought that was interesting. Like it was reminiscent of that. This. I know it's not the same exactly, but just came to mind. But it's not an impact, that's for sure. Like just the mere fact that it has a mirror as well as has an additional nearby hexagon. Like this also has a hexagon, by the way. So like the hexagon isn't like, why is there a hexagon on this impact structure and then a second one adjacent to it? It doesn't really make sense. Coupled with this one, it really makes no sense. Even if we look here, there's probably another one like staggered, and maybe even a square, like the platonic solids kind of shapes that are not like impact structure really at all. Anything, I'm sure there's nothing of that nature referenced in reference to impact sites where they're like hexagonal. I don't know why that's passing the test, besides just because what else do we do except for just label it the same thing that we've been labeling all the other things like it, even though none of them are that thing. Because they're caused by currents colliding underneath the crust of the earth that then upwelled in locations that because of the collisions. just everywhere. 1.6 billion. Gawler's range is red. Hexagonal patterns. Super volcano. Shows magma pool in magnetic anomaly map. That's what from this video. Maybe I can pull this up. Pardon me. Let me just at least find it. This one, considered to be a super, or yeah, impact. Wait, is this the one that has it? No. Here we go. Pardon me. This region, Gawler Ranges, is considered to be a super volcano. And then underneath it has a giant lava field in its magnetic intensity image. So like the blue is considered to be a giant lava field. Presumably where the red is like higher density structures within the flow of the field, right? So that's the first time I've in any way heard any concept or reference to there being magnetic intensity map lava field below the surface as like what's going on. Okay, and what shaped it? The flow, that there were flows within it that shaped it. Okay, something else. And he mentioned this region was formed something like 20. I think it was here. Pretty sure it was there. And then there's like river. There's a river an ancient river that went here to these canyons that are like more canyony than the Grand Canyons. And this river was around 20,000 years radiometric dating. So there's that, just curious. Tasmania geologically is more related. This is interesting. Tasmania is more related to North America and Antarctica than Australia geologically. So it would have been here. I mean, it's pretty close. I guess it's pretty close. It would have been adjacent to both. Like, obviously, it would have been connected to this one, to Antarctica. Before the Earth expanded, it's easy to, like, join those. But to take this corner and in any way, like, connect it up to North America is a little more odd. But it really, like, here was here, which was conjoined to basically to here. Maybe it was like over here. That'd be interesting, like here. Like it was here and got dislodged out of the way. Does that make sense? And then it moved down. I mean, it seems like these things can like rejoin, like this region rebonded across this current flow that just like connected the regions energetically, because this moved from up here just down. wonder if it's possible. Like these portions of this island extending into the Philippines, I'm fairly certain we're actually physically conjoined to the Philippines, like here and here. Maybe to here and here. And then maybe like this chunk is somewhere in there. I don't know. Or down here somewhere. Okay. Let's see. So then, yeah, so that, I mean, that honestly, I'm gonna have to think about that. It's possible that Tasmania was like essentially effectively behaving as a plug between the current that like was essentially was flowing from under, let's pull up the thing. Let's pull up this thing from Papua New Guinea across and into beneath South America where it fans out here. I know, sorry guys. I'm just so fast, huh? What the fuck, dude? Came through this region, crossed this current, which is then kind of forcing it down, I guess. But there's another current coming up this way that's squeezing the current coming between them. That's then shoots out this way. And this current fans out under South America. But maybe over time it just continues to push on the boundary here. Like it. And like move Tasmania down. I don't know if that makes any sense geologically. I know, like, I'm just trying to explain how it could have been touching North America. I don't know if it has to be. Maybe just being in the current here would bring, like, parts of North America with it, but it's a little odd that it's not, that it's not more related to Australia than North America if it's not, like, more directly conjoined to it. But at the same time, I'm not sure how it would be connected to Australia or to Antarctica and to North America. I'd have to look into the data more and see what they're actually referring to exactly. It may be that it's just before the Earth expanded details that are just I'm not even contemplating towards enough to realize what's going on or aware of enough details to. Okay, next detail. Gold bearing quartz in Australia looks similar to gold elsewhere, such as California, so I started watching videos about gold because it's really informative geologically about, like, I think something's going, there's something, like, to take from the gold's, like, locations in terms of, like, oh. I'm pretty sure it sheds light on things, so that's what I'm thinking. More so than like trying to find gold. I honestly, my thought is like is probably best there in terms of like the stability of the planet. Like I'm pretty sure this is my thoughts is if we don't mine like what I'm coming across is that we're finding like ancient gold beds. And I'm like, okay, that means that there was gold here before the earth expanded, and they probably knew and didn't actually like choose to go for it because they knew that the earth needed it to like continue to survive, and it was just throughout it, like it's throughout regions, and it's probably like behaves as like an energetic transfer, like component to like keep the system behaving and like living, because then like it's possible, like as we mine and take parts of these systems, that they're just gonna like collapse energetically to a new steady state, which will then entail like cataclysmic reactions in ways we don't anticipate, such as earthquakes of fracking and so on. And I don't know what CO2 sequestration might do in this whole thing, but it don't seem like the best idea. I ain't gonna lie, that seems straight up stupid. So there, so there's gold bearing cores like throughout the Pacific. So now I'm trying to get a bearing on where is this gold at, because my thoughts are that this supernova of this like Pacific coast region. I know it's ridiculous to some people. It's across scales, so it's an accurate term. The nova or whatever, this system that was like radioactively decaying pretty much because of the like unstable environment. It really needed like continuous currents, and it was breaking down from reduced currents maybe, and just started to break apart and send just bursts of energy out of it. Da 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 da. So my thought is like, if there's gold throughout the region, it's because there's a supernova that just happened. If we're finding gold, like here, 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 probably down here, is because there's a supernova that happened right about here. And just to like send energy into the surroundings, causing the ring of fire, but in the process causing like the deposition of materials, like supernova materials like gold. So these are called orogenic gold deposits, the ones that are formed as part of mound building processes along the boundary of continents. Just basically in those locations. There are ones that are older and younger. The youngest examples are from the Pacific. This is all just from these videos. The ones I was initially looking at, I guess, maybe here. This channel. These are from this channel. Especially him, this guy, whose name, Richard Goldfarb. It's gotta be gold in his name. But he seemed to be quite knowledgeable on the gold, and was saying that there was a time that gold was believed to be called epithermal gold. These golds, orogenic, meaning mountain building process related gold deposits, that they were considered to be epithermal gold, which was a previous term associated specifically with granites, but then it was determined that the granites were not actually where the gold was sourced, and that the gold later intruded the granites with seems to be especially along veins of quartz that have especially like almost like multiple intrusions at the same vein that like cause layering at one side or something of that nature, that then along the boundary, this video talks about it closely, along the boundary, the called the lamination layer or something of that nature, it has a lot of gold there. So like there's something to the like actual mechanics of things going on in a celestial cosmic physics sense that can be gleaned from this. That's so cool once we can actually piece it together. But the gold actually associated with metamorphic rocks at moderate temperature and pressure. So that's kind of interesting. It came in at moderate temperature and pressure. Along channels of pressure that was pushing it in pretty much along the channels. Gold had to be in rocks to move during metamorphism. So it's found in metamorphic rocks. These orogenic gold deposits are found in metamorphic rocks, meaning it was heated. And so there's gold in the heated rock, so they're saying it had to be there already in order to be moved during the heating. And so that's pretty much they're saying that the gold was brought there by the heating process, moving, causing metamorphism and allowing the gold to move in the flow. Most would argue it comes in during seafloor movement processes where sediment of ocean floor has pyrite with high gold content intermixed background. So there's a lot of pyrite with a background of gold apparently in just ocean floor sediment. And apparently it's accreted, added to continental margin. And so as it is accreted, added to continental margin, the gold is mobilized and like almost like siphoned through, it seems. I'm not quite sure if the interpretation is valid. I just wrote it down because it's related to a supernova of a particle on the surface of the planet. I'm just saying, dudes. Active continental margins, collision terrains, then strip. So at active continental margins, collision of terrains causes strike slip movement apart. Collision. Let's just look up strike slip just to make sure I don't actually know which one it is. Vertical or nearly vertical? Oh, wait. That's vertical. Why does it say vertical? Isn't that like sideways or nearly sideways? So they're saying basically this when the strike slip at collision margins, continental margins, occurs, earthquakes occur, and like basically movement allows for pressure to push things that are like held under high pressure to escape, I guess, and that includes gold deposits in orogenies of mountains when that was what was occurring at the margins. At the you know what? That just made me think of, I wonder if that was based off of especially California, which Baja California, raised by California itself. Oh, during its motion to British Columbia, and maybe it due to being caused by the supernova and like moving Hawaii practically just makes me think of the forbidden island of Hawaii now. Why is it forbidden? um okay. But maybe it like left behind gold in the process in that case. I don't know, just an alternative thought. Ancient gold beds are analog of what we see in North America. This is what they were saying. And I was like, oh, ancient. Thinking of like real ancient. But then they said the gold belt in Central Asia into Western China is from 250 to 500 million. Gold belt, Western China. What did I say? Asia to China. Geology. That's probably it. Gold. Oh, it's related to Tarim Basin too. Okay. So this is above. Okay, it's basically fed in by the current from here. And it looks like it's kind of this region above Tarim Basin, which is around here somewhere. I think it's here. I might be mistaken. I think it's that. But I might just want it to be that. And let's see. Let's just remind myself and give you guys peace of mind that I am referencing the location accurately. 82.71. Okay. It's a little easier just to write it down. 82.71. 82.71. And then 39.23. Oh. Whoa. 39. Okay, I kept going though. 39. 82. Interesting. I really am not at the right location then. 82.7. It's like here. What is right here? And let's say also right here. 86. 32. Like, can I read what I just wrote? Oh, it's up here. Oh, now I can kind of... Now I feel like I can see that. Oh. It's above the Tarim Basin. So that there is here. So let's see where this is. Basically leading up to Tarim Basin. So inclusive of some of this too. Which is probably, I don't know where Tarim Basin, let's see like the very, this spot of Tarim Basin. Okay. 40.63. It's pretty much at that kind of elevation. Elevation. I guess it's like here. I don't want to map out as every boundary now. I really thought that I had found it to be there before. I feel like I've referenced it there a lot of times. My bad. And even maybe noticed at one point, I think might have happened, that it wasn't there and I kept referencing it. That's okay. But let's go back to this. This boundary is up to there and across all the way to the, all the way over to pretty much over here. So I guess it's really like here with some boundary somewhere. So it's definitely related to this inlet. So why was I looking at that? Apparently there's a bunch of gold in this region somewhere. From 250 to 500. Which is really probably because it's related to novas as well, just different scales. Like there was probably major nova events going on here, just as there were down here. Like there was an actual super volcano here, but there was a large igneous province here. Maybe there's more going on in the 500 to 250 range too. That just wasn't as like historically detectable and known to be like as much of a benchmark in history as the Siberian traps, but maybe other things that I'm not aware of. In essence. I took a bunch of notes. I don't know if I want to read everything. Low angle faults at Wood Point, at least. Higher in gold. So whenever there's lower angle faults, they're higher in gold, infilled by quartz. That then have, like, the more there's layering on the side with lamination, the more gold there is, but not to, like, give information. It seems like a mining process necessary to really find it, but it's not really necessarily good because it might end up killing things like the environment itself, or at least causing it to decay to a different energy state. Maybe it keeps things clean, practically. Like it's gold. It's just a catalyst to keep things running smooth. Take it out and it just starts clogging up. The energies start like not being able to flow as easily. So then there's a place called Macquarie Arcs in the west of Sydney. That's another gold spot, Macquarie arc. Geology. Which this guy was talking about in this video. Maybe let's check out a paper on it. Lac Lane origin of New South Wales, Victoria, and eastern Tasmania is the best understood element in the eastern Australian Tasmanids compass. Okay, encompass continental growth in a Neoproterozoic passive margin setting and a Paleozoic Mesozoic active margin in East Gondwana, bounded to the east by the Pacific Ocean in the Ordovician, which is during the Earth's expansion. The suprasubduction zone elements in the Lac Lane origin is the Macquarie Arc. So it's hypothesized that some kind of island arc formed off the coast of Australia that then collided with Australia at a later point, although I'm not sure what to make of this structure, this kind of time frame. And then it has conodonts. So conodonts, just like shalograms, never existed. Know this about conodonts: we've never found a conodont. All we found is like literally teeth. I'm not even sure what that is. Let's see. This. It's not from an animal. It's from a current through like basically some like elongated structure that formed also in the current that then had a current flow through it, where within that elongated structure it had physical nodes that popped and created jagged teeth-like structures that we then say conodonts. There's something about conodonts that is kind of ridiculous for it to be a living creature. Like, it changes its diet completely at some point. It's something weird, like, as it grows up. As they get bigger, they start to eat different rocks. They eat rocks, and as they get bigger, they start to eat different rocks. You sure that's not like some kind of like molecule thing interacting with the environment? I know how crazy it sounds. Preserved articulated association of conodont elements. I'm not sure. That looks like an eyeball. Oh my god. It's like out of a movie, though. The freaking ground, like a horror movie where the ground starts to emit like teeth rocks radiating from the ground as like sharp projections start clipping people who don't know where to be because I don't know if there's anywhere to be really when it's global, except for on some kind of arc, maybe. I don't know. I don't know, maybe. Okay, so let's keep going. But the conodonts there, in Macquarie, in this location, Macquarie, they oh yeah, that's right. That's fine. Let's get this video. This one. I gotta show this. I know it's in there. They even show an ammonite right there. How close to the ammonite? Somewhere in here, they show Australia. It must be around here. With like a river. I think it's this one. Yeah, what the... There's the Conodon. It's gotta be from this one. There it is, there it is. Here we go. In the Ordovician, the Paleo-Pacific Ocean was thought to be like this, so let's see. I guess I could have just immediately looked for Ancient Pacific Ocean. Ancient Pacific Ocean. Let's see if we can find more than just that image. Gee, Australia map. I don't think. Maybe paleo. I don't see it anywhere. But immediately struck me because I've been saying, let's just leave that there. Photoshop images? No. I don't mean to hide my folder. I just think it's kind of annoying in some ways. I don't know. Here we go. Australian ammonite. Final chamber here with the outgassing generally going through this way. It's an inlet through here that was up this way. And then it went around. The boundary of Australia is somewhere around here. Like here, this boundary. Let's find it exactly. A little out past this like magnetic field structure that was present. This beam seems to have cut across it. Maybe from over here. I don't know what's up with that right there, but. So I was thinking though, like, is it elevated basically in the region where the ammonite is, except for where there's some current flowing, like some matrix being deposited, if you will. Yeah, so there's that. That to me was pretty exciting to see. That, so I think this, I really am starting to come to the conclusion that this Ammonite type thing was going on pretty early, and then it finished around 300 million years. This one was formed, it seems like, based on the, I think it was called Alice Creek, something or other. Okay, sandstones reach to the southeast corner of Australia, so this arc that have been talking about that I haven't pointed out where it's at, it's to the west of Sydney. Like, there's a couple structures in here, like, just kind of straight little things that aren't all in anything specific. Maybe we can find an image without resorting to the video again. There we go, the purple. A couple spots around and there. It's nothing immediately popping out shape-wise. At least not, I don't know. But then there's sandstones that reach the southeast corner of Australia. Apparently there's also, I don't know, I guess this color is granitic. And then volcanic. Granitic, volcanic, and alloturbidites. I don't know what that is. Okay. They mentioned that this region is maybe similar to another volcano. Sarychev volcano. Which is over here. I believe it was around here. I don't want to actually find it directly, but one of those. Then I'd have to put this down, and it doesn't really matter because I'm just moving on past it. Maybe let's check out something more informational about it. Oddly, I guess we can just go here. This one's maybe more active. Ew. Okay, then this is the last bit of information for this video. Gold, copper, magmatic, hydrothermal. So gold, where there's gold and copper deposits are mainly found associated with young volcanoes along the Pacific Rim. Is what they said in one of these videos that from this channel. Southwest Pacific, Philippines, Indonesia, Russian, Far East Russia, Western North America, and the High Andes, which are all pretty much in the like ring of energy propagation from a center point that exploded. I mean, it's funny because it's true. This, maybe I can find this one because the imagery was spot on. Let's go back. perhaps the... I'm not sure which one. Maybe... I'm trying to think where it was. Maybe this one. No. Which one did I just click? Okay, not that one. Was it on this one? I don't think so. Maybe this one. It's basically inside of a mining, like, not cave type thing like this, but more out in the open with like stripping the ground. It must have been in that video. I watched too many. I watched too many. It must have been in here? I don't know. Sorry, guys. It's pretty cool if you want to stick around. Or there it is. It's this hole. This hole. There it is.
And turning around.
Oh yeah, I'm so glad that I'm actually bringing up him speaking, because he says convecting and turning around. I don't know why I didn't mention that. Rises and collects in a huge batholithic chamber, is very active and convective in the process. Porphyry stalks come off of the top. That's what I wrote down. But remember, chamber, inside of a container, a current flows and fills it and convectively flows like a planet. That's what he's going to say indirectly.
Porphyry mineral deposits.
Porphyry deposits like those found in the Cadia Valley are a member of a class of deposits that are broadly called magmatic hydrothermal, that they involve melting of large volumes deep down in the Earth's crust, down into the mantle. That material rises up and collects in this huge batholithic chamber that's down about 6 to 10 kilometers. This thing is very active, and it's convecting and turning around in the process. Little porphyry stock.
Look at that. I know they like outlined it, but
It's come off the top, and
it's just these like flames.
Dissolving a hydrothermal fluid, and doing that is extracting all the copper and the gold that one finds in the magma, and it is going up, following the porphyry intrusions up to about a kilometer to 2 kilometers below the Earth's surface, where the rocks are fracturing and the metals are being deposited along with quartz.
Metals like copper and gold react with sulfur to form sulfide minerals. These new minerals are concentrated around the porphyry intrusions, a favourite target for mining geologists.
Yeah, these are actually some of the most beautiful rocks in the district. But I'm biased.
Okay. Before I go watching this. So yeah, like that's certainly got physics, like real physics. I don't mean just like applying physics to geology. I mean literally physics, like a star, dudes. Let's go. Let's go.